Hello and welcome to New Scientist Weekly, your curated selection of the week's science stories. I'm Christy Taylor in New York.
And I'm Timothy Revel in London. This week on the podcast, we've got the latest on Australia's Great Barrier Reef, a mysterious attack of jammed GPS signals in the Baltic region, and a look at whether snakes can recognise their own smell.
I love a good snake story. Plus, we introduce you to what may be the itty-bittiest, eensy-weensiest galaxy in the known universe. But first, we've got the news of an incredible medical procedure that has been tested in a person for the first time. The procedure involves transforming lymph nodes into little miniature livers that could, in principle, ease the workload of the person's actual liver. And that would be incredible news for the thousands of people waiting for liver transplants around the world. Health reporter Grace Wade has more. Hey, Grace.
Hi.
So, Grace, tell us a bit about this therapy. I mean, we're not even talking about mice today. We're talking about the human testing phase.
Right. So there are 12 people with end-stage liver disease who are set to receive the therapy as part of a clinical trial. And the first person went ahead with it last month. We won't know for a few more months whether the treatment is successful, but if it is, it would revolutionize the treatment of liver disease. If you want to look at the most exciting possible outcome, this therapy could potentially even eliminate the waitlist for liver transplants within a few years.
I mean, that's a huge potential and a very, big, if true, thing to consider, Grace. So let's take a step back. How do you begin to turn a lymph node into a liver in the first place?
Yeah, so the therapy works by taking liver cells known as hepatocytes from a donated organ and injecting them into lymph nodes throughout the body. There, the cells proliferate, divide, and develop blood vessels, transforming the lymph node over time into a fully functioning mini liver. The idea is that these mini livers will make up for some of the lost function that happens in liver disease. But exactly how these cells end up organizing into a tiny functioning organ isn't exactly clear. The researchers who developed the treatment believe it may have to do with the fact lymph nodes are really well suited for cell survival. One of their many functions is housing important immune cells. When you have an infection, those immune cells rapidly proliferate and divide within the node. So that means that lymph nodes are essentially like mini bioreactors or incubators.
When I first heard about this story, I thought it was that you'd grow a liver using the lymph nodes and then move them somewhere else. But the idea is actually mini livers distributed around the body, right? That really blows my mind. You said we won't know for a couple of months if the first human research participant is seeing the benefits yet. So what's the evidence that this treatment might actually work at all?
Well, that comes from other animal experiments. Researchers have found they can transform the lymph nodes of mice, dogs, and pigs into livers using this therapy. Those animal studies suggest it will take a few months for the cells to organize and develop into a functioning organ. So while the person has so far experienced no complications from the treatment and is doing well, it's much too early to know whether they will experience any benefit.
Lymph nodes themselves, they're actually pretty useful. And as you mentioned, they house lots of immune cells. So can we just afford to turn some of them into mini livers? Is there a risk we might miss them?
Well, obviously we can't say for sure since we don't have any data in the humans just yet, but there is no reason to think it will have any serious consequences. That's because we have roughly 800 lymph nodes throughout our bodies, so we can spare to lose a few. In fact, lymph nodes are commonly removed in cancer patients to see if the disease has spread, and we know in those cases there aren't lasting immune effects.
I mean, this sounds really promising, and you talked earlier about, again, the potential to eliminate the wait list for liver transplants. And I guess I'm just left wondering, how beneficial this treatment could be if it does end up working so well in humans. How many people might be affected by a new way to offset liver damage?
I mean, if it works in humans, it would be groundbreaking. In the U.S., almost 10,000 people with end-stage liver disease are waiting for a liver transplant, and many, many more aren't even viable candidates for a full transplant. So this treatment could have a huge impact, especially since researchers estimate you could treat 75 people this way using just one liver. This approach could even help treat other conditions, so the researchers have shown some success in using it to grow mini kidneys and thymus glands in animals too. It's all really exciting.
I'm picturing future humans just like with organs of all kinds just distributed all over their body.
Decentralize your organs.
It's time for a field trip. We are going to visit the Great Barrier Reef, the world's largest coral reef system, which spans 2,300 kilometers, 14 degrees of latitude, and a uniquely wide range of marine ecosystems. Now that we're there, imagine an island within that vast realm that is so protected that no tourists are allowed to visit. No fishing is permitted anywhere nearby, there is no pollution, and development is forbidden. This is One Tree Island. It's 100 kilometers offshore from the Australian mainland, and a wall of surrounding coral means that there's only a few hours a day when the tide is high enough for a boat to access it. But once you're there, it is a paradise of turquoise water, coral arrayed right up to the waterline, and seabirds, as they do, flocking noisily. It is really the cliched island paradise protected by the reef. Our reporter in Australia, James Woodford, has just returned from this remote coral refuge, where he joined scientists assessing the impacts of an unfolding environmental disaster, the bleaching that occurs at high water temperatures, which threatens the survival of coral worldwide. Welcome, James. It sounds like you had quite an adventure to get us this story.
Thanks, Christy. Yes, it's true. There's not many places difficult to get to as One Tree Island, and it's easily one of the most stunning and isolated spots I've ever visited. Even getting there is such an arduous journey. It's a 80-kilometre ferry ride from Gladstone on the mainland to the research station on Heron Island, then a 20-kilometre speedboat ride that has to be timed carefully with a high tide.
Right, yeah. And does it really only have one tree Island?
It is tiny. It's less than 4 hectares, but I can attest that there is a small low forest with multiple trees covered in seabirds. Though, apart from the research station, people are not allowed to venture above the high tide mark.
All right, so you went on a long trek to a tiny island. And as I mentioned, the reef as a whole has been experiencing bleaching this year, which, as we know, is disastrous for the health of coral. So, why did you opt to trek all the way to this particular island, One Tree Island?
Particularly because it is so protected. The past couple of months, there's been a marine heatwave in Australia's Great Barrier Reef, and authorities have confirmed that the entire 2,000-kilometre length of the park has been experiencing a mass coral bleaching event. And this is the 7th such disaster since the late 1990s. In the past, though, through sheer luck, cooler water currents, and the fact that it is at the southern end of the reef, the Capricorn Bunker group of islands, which includes One Tree, has been largely spared from mass bleaching events. But this year, in early February, water temperatures hit the mid-30s, and in Fahrenheit, that's the mid-90s throughout the region. And that's the kind of temperature you'd expect in a hot tub, and so warm that scientists that I spoke to, they could only work in that water for half an hour before they began to overheat. And of course, the corals began to bleach and die. Here's University of Queensland coral expert Selena Ward, who came with me to One Tree to explain how corals respond to water as hot as this.
So corals live with single-celled microscopic algae living inside their cells. And those algae, the common name we use is zooxanthellae, they photosynthesize within those cells, and they give over up to 100% of the coral's energy needs to the corals. Now, when a coral bleaches, that disrupts the photosynthesis in the zooxanthellae, and they lose a large percentage of them. And the zooxanthellae are in very high concentrations, about 1 to 5 million per square centimetre of tissue. So that's what gives corals that brownness that you see across the reef. So when they depart, the corals pale, hence the term bleaching.
So the coral and the algae part ways, and then the coral don't have a food source anymore. So what did you see in terms of the consequences of this when you were out at One Tree?
Look, I was expecting it to be bad. I've seen some of the media reports and some of the reports coming out of the government agencies, but I just hadn't realised the scale. In places, up to 100% of the reef is bleached. Just at one tree alone, we dived about 10 different sites, and everywhere was the same. Normally, corals that are healthy are a kind of a dull brown and a dull greeny brown kind of colour. And a lot of people who come to the Great Barrier Reef are a bit disappointed that it isn't as colourful as they would expect. So the thing that really amazed me when I got there is that most people just think that bleached coral turns white. And in some cases that is true, but there's another extraordinary and exquisite phenomenon that also happens when corals bleach. Part of their stress response is to fluoresce. So everywhere underwater around both Heron and One Tree Islands, there were vast stretches of coral reef that were just an array of different colours, blues, greens, pinks, almost every colour that you can imagine. And it was just such an extraordinary spectacle to see. And even though it is unnerving, it is also incredibly beautiful. And this phenomenon is being reported across the entirety of the reef. Even those who are working there every day have been shocked at the scale of this fluorescing. Here's Stuart Kinnenmonth, the manager of the Heron Island Research Station, immediately after visiting one highly fluoresced dive site with me.
Yeah, to see a whole reef going from being fairly healthy, pretty robust, greeny browns, and then seeing it just go into this bright white and blue fluorescent image, it's amazing. It's a whole transition overnight. A month and a half ago, that was a comfortably healthy sight.
Oh my gosh, James, this all sounds so alarming and, extraordinary as far as circumstances go. Also, as you mentioned, this is the 7th such mass bleaching event that the entire Great Barrier Reef has seen. So what comes next for the coral once the water cools back down, as hopefully it will soon?
Yeah, the researchers and reef managers are holding their breath, Christy, and crossing every part of their bodies that can be crossed, that the water temperatures cool down. It is agreed now that the heat wave has peaked, and bleaching does not equal mortality. If the ocean around the reef continues to cool, then the symbiotic algae will be able to return to at least some of the corals, and the reef can begin to recover. But the biggest fear is that there's going to be another hot summer next year. The coral damaged over this summer really does need time to recover. All the researchers agree that another big bleaching event will be a disaster that may irreversibly damage one of the planet's greatest natural wonders.
James, thank you so much for bringing us this report.
Pleasure to join you, Christy. Thank you.
You can read more about James's trip to One Tree Island, as well as see photos and video he took of the reef, and that's all linked in the show notes or at newscientist.com/podcasts.
And after some tough news like bleaching coral, maybe you're looking for some escapism. Well, don't worry, we're here for you. This week's Escape Pod brings you escape, quite literally. Take a listen to learn about the exploding beetles that use chemistry to evade predators, and all the work that went into humanity's real-life escape from Earth's gravity, and the extremely impressive abilities of free divers, some of whom just want some peace and quiet very far from the ocean's surface.
And coming on next week's Culture Lab, half the world's population menstruates for a large proportion of their life. Your period may be a source of significant, debilitating pain or a key indicator of other health issues. And of course, it is vital to producing new humans. So why is there so much misinformation and social stigma preventing us from understanding how our bodies manage this very important and unique process? Gynecologist Jen Gunter joins me to talk about her new book, Blood, and all the things that it ought to be much, much easier to talk about.
People are on airplanes coughing and sneezing without wearing a mask, and somehow walking to the bathroom with a tampon is gross. Okay, record scratch, freeze frame. Let's just talk about what's actually disgusting.
That's coming Tuesday.
Next up, we've got news of a record-breaking GPS jamming attack that Russia is suspected of conducting. GPS jamming is a form of electronic warfare that has been on the rise in Europe since Russia launched its invasion of Ukraine in February 2022. And both military and civilian aircraft rely on GPS to work out their locations often, so jamming the signals is an extremely effective way to cause disruption. The latest attack impacted the navigation of more than 1,600 aircraft over the course of a couple of days. Technology reporter Jeremy Su is here to tell us more about it. Hi, Jeremy.
Hi there.
So global navigation satellite systems such as GPS, they rely on signals from not just one, but multiple satellites to send precise location and timing information to devices on Earth. So how would an adversary even go about disrupting GPS signals? It feels like it's quite a hard thing to do.
Yeah, the main issue is that the GPS signals from space are relatively weak, which means that more powerful radio transmitters can potentially drown out those signals. There are also GPS spoofing attacks that can actually make GPS receivers appear to be in the wrong locations. And this latest incident is just one of many in recent years when parts of Europe seem to have experienced GPS jamming, to the point where many independent experts and government officials have flagged Russia as the most likely culprit.
So it's not the first time this GPS jamming has happened, but this latest incident was uniquely long and disruptive. What do we know about it?
So this latest GPS disruption comes from what some analysts have termed the Baltic jammer. The Baltic jammer has been known to analysts for some time now and is most likely located in the Russian city of Kaliningrad, which is located on the coast of the Baltic and sandwiched between the countries of Poland and Lithuania. These GPS disruptions began on March 22nd in a region near the Baltic Sea and lasted for 63 hours and 40 minutes until March 25th. It's the longest single stretch of activity yet recorded from this Baltic jammer, with parts of Sweden, Germany, and primarily Poland also being affected. And as you noted, this really impacted GPS service for hundreds, if not thousands, of aircraft, which use GPS to safely share airspace with other aircraft and also to help plot fuel-efficient routes.
Safely sharing airspace seems important. So does this jamming attack mean airline passengers and others flying in these parts of Europe should be worried that it'll happen again?
So the good news for now is that the air crews and air traffic controllers now know to rely more on radar and land-based beacons in all these affected areas. But that really adds to everyone's workload, and that in turn can raise the risk of accidents.
Is there some kind of long-term fix? I mean, can you jam the jammers or anything on that level? Or can we at least find a way to rely less on GPS in maybe a more long-term and sustainable way? I don't know. Is anyone developing more effective backups, for example?
In the long term, it might be possible to have alternatives to GPS as backups. China and South Korea in particular have been building on an older GPS alternative called e-LORAN, which uses ground-based radio transmitter towers to broadcast extremely powerful signals that are difficult to jam. And China has also been building a national optical fiber network that provides a similar GPS backup service. But Europe and the US have yet to commit to a serious GPS alternative in a big way.
All right, now it is time for Lifeform of the Week. This week, our star is that most wriggly of reptiles, snakes. In a study published this week, garter snakes have passed a smell-based version of the mirror test, which hints that they may have some form of self-recognition, a trait once thought unique to a small handful of species, including us. Chen Lai is here with the details. Hey, Chen.
Hey.
Okay, step one, I think we need to explain the mirror test. Why is it supposed to be such a good indicator of self-recognition in animals?
So, the mirror test was first developed in the 1970s by American psychologist Gordon Gallup to see whether an animal could have the ability to recognize themselves. It involves putting paint on an area of an animal's body that they can't see without a mirror, such as their forehead or somewhere on their face. If the animal touches the mark when looking in the mirror, it suggests that they are aware that the reflection is actually of themselves and not an image of another individual, hence self-recognition. A handful of animals such as orangutans, roosters, and horses have passed this test.
Yeah, I remember we talked about roosters specifically passing this test just a few months ago, and so I guess now researchers have decided to try it on snakes too. My biggest question is mostly how a snake would touch its own body if it doesn't have hands at the end of the day.
Yeah, that is a very fair question. So snakes are much more smell-based creatures, so they rely more on their sense of smell than sight to navigate the world. So researchers challenged them to an olfactory version of the mirror test that conveniently skips over the hand problem. To do this, the team collected the scents of eastern garter snakes and ball pythons by wiping cotton pads along their skin, which secretes odorous oils, and then presented each of the snakes with 5 scents. Their own scent with a little bit of olive oil added, just olive oil, one of another snake of the same species, and one of another snake with a bit of olive oil.
I see. So their own scent with the added olive oil is kind of the smell equivalent of adding a paint mark on the forehead of another animal in kind of a visual mirror test. It's sort of me plus something that's not supposed to be there. That's the kind of thing that they're showing.
Yeah, exactly. So the team found that the garter snakes performed more long tongue flicks in response to their own modified scent compared to the rest of the scents. This long tongue flicking behavior pretty much only happens when snakes are interested or investigating something. So the garter snakes are probably thinking, oh, this smells kind of weird. I shouldn't smell like this, maybe.
That's the garter snakes. What about the ball pythons?
So interestingly, they found that the ball pythons reacted the same way to every scent, even modifications of their own scent.
So does that mean ball pythons, they don't self-recognize?
Yes, or at least not how it's measured in this mirror test. Ball pythons are a lot less social than garter snakes, so it could be that social species are more likely to have self-recognition, or it may be that more social species are just more likely to interact with the experiment.
Chen, it seems like in recent years we've been finding more and more animals that kind of at least at first glance seem to be passing, variations of self-recognition tests. In the case of the garter snakes, though, can we be sure? What does this all mean?
Well, we can't say that garter snakes have self-awareness quite yet, but this is the first evidence of potential self-recognition in reptiles, according to the researchers. So we very much tend to think of snakes and lots of other reptiles as, quite non-cognitive, very instinctive animals, but it turns out the picture may be a lot more complex than we thought.
I was going to say, I know that researchers have been spending a long time looking for self-awareness in podcast hosts, but have yet to identify it. Christy, I've got some fun space news for us this week.
Is it the eclipse?
It's not the eclipse, but we will come back to that. Researchers have found what may be the smallest galaxy in the entire universe.
All right, when I hear the phrase small galaxies, though, I'm still thinking this must be a very enormous object, right?
Yeah, galactic rarely means tiny. But in this case, it's pretty unimpressive, even for a galaxy, it's very small. And this is a clump of 57 stars that astronomers are actually calling impossibly small for a galaxy. But it's not breaking apart as a cluster, which is why it's a candidate for galaxy status. It currently goes by the name Ursa Major 3, or Unions 1.
All right, well, 57 stars does actually sound eeny-weeny. Where is it, though, and how did it get there?
So this clump, it's orbiting our Milky Way. It's a satellite of our galaxy, which in itself is not actually that weird. We have many satellites. But its mass is only about 16 times that of our Sun. And if it were a conventional cluster of stars, the gravity of the Milky Way should have pulled it apart. So the researchers who discovered it are saying that if it's a galaxy, it should also be full of dark matter, which would be able to act as a kind of gravitational glue to hold the stars together. But amazingly, the dark matter would need to be a mass 1 billion times that of our Sun in order for it to account for the current velocities of the stars.
That is a lot of ifs. Are there any possible explanations for, an eeny-weeny clump of 57 stars that are not it's a galaxy?
Yes, but those are looking a bit less likely. The other possibility is that Ursa Major III, or Unions 1, is not a clump, but a star cluster, which is a group of stars that are formed from the same cloud of dust and gas. And if that's the case, it's not going to be for this world for much longer. It would only last maybe 400 million more years before the gravitational forces acting on it should tear it apart. But again, the research team think it's more likely. What we're looking at is the smallest, faintest galaxy yet observed in the universe.
All right, guess what? Speaking of small things, babies are even cooler than we thought they were?
I didn't realize babies were that cool, but how so?
I mean, babies are cooler than me, I think, on any given day. But when I say cool at this point, I mean that their brains seem to register quite a lot of what they experience in the womb. We've long known that they can hear what's happening around them, and studies have shown that infants of bilingual parents have brain differences even within days of birth. So now we know that they're also remembering the sounds and rhythms of nursery rhymes that they hear in utero without the music or the tune. And all this could say a lot about when and how language development begins, whether that's in the womb or not.
That is pretty cool for such tiny humans. How do we know this?
Right. So there's research from over 10 years ago that determined that infants could recognize Twinkle, Twinkle, Little Star after being exposed to it in the womb. And they did this by measuring brain activity as the infants listened to the song after birth, and also at 4 months old. And the unexposed infants didn't have particularly strong brain responses, but the exposed infants did. But the researchers weren't sure if the infants were responding to the rhythm, the melody, the lyrics, or all three components. So bring in the new research, a team in Austria recruited pregnant women to play the spoken version of one of two different German nursery rhymes to their abdomens twice a day. This was from week 34 of their pregnancies and on. And the researchers would also sometimes alter the rhythm or scramble words up in the recordings. Then, after the women gave birth, they measured the brain activity of the infants while playing both the familiar and the unfamiliar recordings. And in this case, what they learned was that the infants registered more brain activity when listening to the unfamiliar or scrambled version, which suggested that they were working harder cognitively when they listened to those. And the original versions of the nursery rhymes would elicit less activity, suggesting it was easier for the infants to follow.
And this has researchers thinking that there's an element of language learning that's occurring in the womb.
Something like that, in the sense that it tells the researchers that babies can distinguish rhythms and tones early on in life, which makes those extremely important components of learning language. Yeah.
All right, one final one for you. If your household chore robot, which I know you've got stashed away at home, Christy, if it was doing a task badly, what would you do about it?
I mean, I guess in this hypothetical case, I would probably just turn it off and go back to making paper airplanes or doing the dishes by myself.
Well, it's funny, I see you more of a slap it on the head kind of person, but fair enough. Now, a research team at Stanford University, they have had success with a different kind of approach, not the slap on the head one or the just turn it off and try again. Instead, it's just yell at it about what it needs to do differently.
I mean, Tim, I know I asked this question about robotics a lot, but is this actually a practical line of research?
I think so, yes. So in this hypothetical future where we all have multi-purpose household robots, it would be impossible to train a robot for every conceivable task. You want it to be able to adapt. So it would be helpful to have a way to interact with a robot where we could then give them feedback on the fly and teach them as they made mistakes. And to achieve this, the team created an AI that can translate language instructions into motor control movements. They then trained a robot with human operators directly controlling two robotic arms to perform tasks, but they also narrated what they were doing aloud to again help train the AI on the connection between language and motor control. This was all used as training data for the robot, and then they also kept some data of the human operators making mistakes and narrating as they corrected those mistakes.
All right, that all sounds very good, intricate and comprehensive training data on both, how to do the thing, but also how to correct the mistakes. How well did this translate into fixing mistakes after being yelled at about it later?
Right, the crucial test. And it seemed to work quite well. The robot was assigned to perform essential household tasks like placing items in plastic bags, using a metal scoop to put different trail mix ingredients in a bag, and using a sponge to clean stuck gummy bears off a plate. Humans would prompt the robot by saying stop or pardon before providing details of what to change, like, I want some M&Ms, maybe, for that trail mix task. And after these verbal instructions, the robot was able to fine-tune its planning capabilities, and on average, it performed tasks 20% better when it attempted them again.
My only critique is that it sounds like all of this was achieved without literal yelling, which actually sounds a lot nicer than I had feared. So, yay, let's politely ask robots to do things differently.
Yeah, I will add, though, that these researchers, they actually turned yell at your robot into an acronym, YAY, and are calling this the Yay robot. So it's all pretty good vibes, even if there's a bit of shouting going on.
Okay, all right. I appreciate that. And one last thing before we go. This coming Monday, April 8th, is the day of a long-anticipated total solar eclipse in the Northern Hemisphere. The path of totality is just a narrow band stretching from central Mexico through the central and northeastern sections of the United States and ending in eastern Canada. And we've been working hard on everything you need to know to celebrate and appreciate this rare event, whether you'll be in the path of totality or not. Go to newscientist.com/eclipse2024 to read up. And if you're not able to attend yourself, do me a huge personal favor and wish us clear skies.
Yeah, I hope you get a good view of that, Christy.
So far, it's not looking good.
That's it for this week. You can read all the stories we've talked about today in the show notes, and there's much more like it on our website at newscientist.com. Plus, if you like the great stories we're bringing you, please give us a rating or review on Spotify or Apple Podcasts. You can share your favourite stories or just tell your nerdy friends all about us. And we'll be back next week. Bye for now.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.